Today, we're diving into the Stanford study on developer productivity. Did you know that about 9% of software engineers are ghost engineers? People who do almost nothing. They're getting paid full salaries, but contribute almost zero actual work. Do you believe that? That's what researchers at Stanford found when they've been analyzing data from over 50,000 engineers across hundreds of companies. This was just one of the findings from their developer productivity study. Make sure to watch this video till the end to catch my interview with the Stanford researcher leading this. We talk about how AI tools are affecting developer productivity, when AI makes developers less productive, does developer productivity also increase code quality, and other interesting questions. So stay tuned. Stanford created a model that looks at your code commits and figures out things like how long the code probably took to write, what the total implementation time was, including all the debugging and QA cycles, how complex the problem really was, and various code quality metrics. The model does all this in under 1 second per commit. Compare that to the hours that it takes a human reviewer. When the model looks at a commit, it's examining everything, the code structure, so your classes, interfaces, and methods. It's measuring quality metrics like cohesion, complexity, and coupling. It looks at implementation details, like how many lines you added or modified, and what dependencies you're using. And it's analyzing architectural patterns to understand the overall design. This gives you insights into maintainability and actual development effort that you can't just get from counting lines of code. Now, here is where it really gets interesting. To validate that this actually works, they brought in 10 Java experts with over 10 years of experience. And these experts looked at a large number of different commits and answered questions about each one. Then they compared the model's predictions to what the experts said, and the correlation was really high, 82% accuracy for coding time estimates and 86% for total implementation time. And remember that the model does this instantly, while the experts took hours. They also discovered that when you ask developers to rate their own productivity, they're off by about 30 percentile points. Only 1 in 3 developers can guess their productivity within the right ballpark. So all of these self-assessment surveys are unreliable. Let me share 2 case studies. First one is they compared 2 teams at the same company. Team 1 was producing more total code, but when they factored in costs, the team 2 was actually 30% more efficient per dollar spent, and traditional metrics completely missed that. The second case was a startup that got VC funding, tripled their engineering team, and expected to triple their output. But what actually happened is output only went up by 1.5x. So they're paying 3 times as much for barely any improvement. The data shows that remote work creates more extremes. You get more ghosts, but also you get more 5x engineers. The best remote engineers outperform the best office engineers, even though the average is lower. The Stanford team has analyzed over 2 billion lines of code from mostly private repositories. This includes private work from real companies, and the patterns are consistent across the industry. At an AI engineering conference in San Francisco, I met with Yegor from Stanford to dive deeper into how AI tools are affecting developer productivity. How do you measure productivity in software engineering fairly?
That's a fantastic question. It's a difficult one to answer. And I think that the way we're doing it is we take a panel of human evaluators and we ask them to independently review code and rate it across a number of dimensions. Think code maintainability, code quality, code complexity, how much time this code would take to implement. Then we aggregate those results and we saw that that panel correlates highly with one another. And then, most importantly, that panel predicts reality. Then we trained a model that replicates this panel at scale, and it can do it pretty fast, pretty easily, and pretty cheaply, with a 0.85 to 0.90 correlation, so exceptionally high. And then our whole hypothesis is that everything a software engineering team does, in one way or another, eventually ends up flowing through the source code, which is like a choke point. And so if you measure the source code, then you can understand the deviations in productivity. So we're not counting lines of code. We're measuring kind of like the functionality that's being delivered by the code. And then through that, that's kind of like the way we do it. I don't think it's perfect, but I also think it's better than existing ways of counting commits, counting lines of code.
Did you track the time spent on prompt engineering, debugging AI-generated code, and teaching AI tools?
We did not do that for two reasons. Firstly, it's complex and it adds like a dimension which you kind of need to take, understand how much time someone is spending. What we did is we basically said, okay, at which point in time did a group of developers start using AI? And then we did compared their productivity before and after. We also then split a team into two groups, gave one of them AI, one of them no, and then kind of tracked them this way. And so that's like a scientifically cleaner way of comparing these things. And it most importantly doesn't require this kind of micro tracking of everything, which is quite complex to execute at scale.
Did company size matter? I'm wondering if the startups are moving faster than some of the larger corporations.
It matters a lot. Company size matters. Code base size matters. What we also see is that within a big company, you might have a small team of elite programmers that are doing something that's a bit maybe kind of like ring fenced or bound away from all the main company or the main organization, right? So it's hard to answer. What I will say is that, for example, YC startups, allegedly have I think a third of them answer that 95% of their code was written by AI. I totally believe that. I think that there is one big caveat in that their code bases are probably 5,000 lines long or 10,000, right? Not that long. They're front end heavy. They probably don't have a huge back end. So there's not a lot of complexity. And so what we saw is that as code bases mature and increase and kind of proprietary business logic or dependencies, AI productivity gains decrease, right? So in summary, I think startups definitely benefit more. AI is a complete game changer for iterating and building fast products. But then once you translate this to enterprise grade applications, the gains are not as pronounced.
Was there a difference between junior developers and more senior and principal engineers in their use of AI tools?
Yeah, so we took a look at that. We haven't crunched the numbers yet, but what I can say is that we've seen everything from senior engineers really leaning into using AI and saying that it helps me a lot because it kind of replaces a lot of the kind of tedious tasks I was doing, to senior engineers saying, look, this doesn't help me at all. We've also seen kind of junior engineers for whom it's very helpful, but what we see is that by using AI, they're not learning core programming logic that they should be learning. They're kind of delegating everything to the AI. And I just wonder if that's gonna be problematic in the future. What I will say is that what matters most here is the language popularity in which the programming codes, right? So if it's something like Java, JavaScript, or Python, something very popular, models have more training data in their training corpus and generally perform better than languages that are a bit more obscure, right? So kind of senior, junior differences are a bit more mixed and intertwined. I think there's a much cleaner discrepancy between popular languages and unpopular or obscure languages.
For long-term success, would you recommend for junior developers to actually use less AI tools in the beginning so that they can get that core skill set of fundamental and first principles before they go into AI or not?
I think junior developers should still lean into AI as much as possible, but they should be diligent around understanding what the AI is writing. They shouldn't just prompt, they should prompt kind of smaller chunks of functionality and understand why they're prompting it in this way, rather than kind of prompting higher level things and then let the AI decide the underlying things under it, right?
Mm-hmm. So stay in control and verify after you've used AI.
Yeah, I think something like that. I think it's probably not reasonable to have juniors not use AI at all. It's very helpful and just understanding and learning, right? And I think we we can't just force them not to use it, right? There has to be like some kind of hybrid approach where you're still learning, but you're also benefiting from AI as much as possible.
There was a mention that sometimes there is a decrease in productivity when using AI tools.
The decrease in productivity was mostly around when languages are very obscure or just old-fashioned, like COBOL or something like this, which is kind of like not used very often and kind of tedious to write, or when there's like extensive, very coupled code bases that have a requirement of inputting so much context into the context window that even agents or models with large context windows think 1 million, 2 million tokens. They are still not able to process this because model performance degrades significantly with context, despite like there being like a maximum context length for these models, right? So yeah, I think it's more, the productivity decreases are more around the languages used and the code base length than anything else.
When teams experienced increase in productivity, did their code quality metrics also change with that?
It depends. Depends on how you define code quality, right? Code quality could be, is the code more maintainable? Is it cleaner to read? Some people like one style versus the other. What I can tell you is that if you use, for example, this thing called code smells as a proxy for quality, then the effect there was mixed. What we also see is that when you start using AI to code, you deliver more work, but a lot of the work you deliver is actually wasteful, meaning that you're kind of like delivering too much and going back and fixing it. So it's rework. And so I would say that you can improve your quality using AI, but you can also like degrade it. And most importantly, you can introduce a lot of technical debt, which is going to be very hard to track down later on by kind of using AI too carelessly.
Based on your data, what would you tell a CTO who is deciding whether to mandate AI tools, make them optional, or ban them?
Would say make them optional with heavy encouragement towards using them. These models are changing almost every month, and you're going to see huge performance increases every month almost. And so maybe, I think what I often see is that people might have tried some of these tools a year ago. They didn't like them because it didn't work out for them. And then they're like, yeah, well, I tried this. It doesn't work for me. And so as much as possible, creating a culture of like experimenting with these tools and kind of learning from them and learning with them as these tools improve, they change and they become better is what I would encourage. So probably don't force anything on people. I've seen lots of CTOs that I work with. They're like, well, we want to make sure that we're getting our money back, or we want to make sure that it's the developers' jobs to lean into AI. And it's almost like they're going to lean into AI as long as they see value and sense in using it. And so then maybe they're not seeing value in it right now because of whatever reasons, right? But in 6 months, in 3 months, this might be different. So kind of like start with the parts of the organization that is going to see the most benefit from AI, implement it there, see whether people like it, and then kind of as these tools mature, deploy it to other more, let's say, parts of the org that are set to benefit less from AI usage.
Would you still recommend people get a degree from a university in 2025 in computer science or a technical field? Is it still worth going to a university?
Absolutely. 100% without a single cent of doubt. It's definitely worth it, although, as you say, this knowledge is available online. In fact, a lot of the Stanford courses that I'm taking, all the material is out there. There's class recordings, there's the homework, there's the syllabus, everything is online. But the thing is that what sets places like Stanford apart is the community and the people that it attracts. And so you go there with the excuse of learning, but what you're really getting is this community, these connections, this network of people, which really elevate your learning and transform the way you think, because there's some really smart people that may be thinking about things differently than you. And so in these conversations and dialogues and this push and pull around issues, that's kind of like where progress is made, right? And so, yeah, I think that if anyone has ever the chance of, studying in a place like that, it's definitely life-changing and would highly recommend it.
This research fundamentally changes how we should think about engineering productivity. If you're interested or want to help validate it across more programming languages, check out softwareengineeringproductivity.stanford.edu. Make sure to like this video and subscribe to my channel. See you in the next video.
Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.